Welcome to Synapsis. I'm Gökçe Özdemir, a biomedical scientist specialized in neuroscience, and Synapsis is a bridge to make medical science more understandable for everyone. The theme of today's episode is slightly different because it's inspired by the recent Netflix binge-worthy series Apple Cider Vinegar. Inspired by the show, I'll use this opportunity to give you a crash course on basic cancer biology, cancer research, cancer treatments, the big pharma, and why we still don't have a single cure for cancer. Me being a scientist might already give you a big clue on what my perspective will be, but I want to say from the get-go that I'm a fan of combinatorial approaches. I don't think it's simply a battle of alternative versus traditional medicine. I believe that both approaches can provide us with important insight, but how you study and combine them can literally be a matter of life and death. So, before more cancer talk, let's do a quick recap of the show. Imagine scrolling through Instagram and stumbling upon a young, vibrant woman claiming that she has cured her brain cancer, all through alternative medicine. No chemo, no radiation, just diet, detoxes, and a natural lifestyle. It's the kind of story that gives people hope, and that's exactly what Belle Gibson sold. Her brand exploded. She published a wellness app called The Whole Pantry, packed with recipes and holistic remedies. People followed her advice, some even rejecting medical treatments for cancer in favor of her so-called healing methods. But Belle never had cancer. It was all a lie. And based on a lie, Belle became a wellness guru. And big part of the story is another character called Milla Blake, who truly has cancer. And she finds prominence and fame through treating her cancer with alternative remedies like juicing and enemas, selling the idea of ridding your body of toxins to get rid of cancer. She's also inspired by a real person who got cancer at the age of 22 and blogged her journey of fighting cancer while refusing the treatments recommended by her physicians. She became a motivational speaker, got a book deal, everything seemed great, but then later she died when she was 29 because her cancer was not cured after all. And she died only a year after her mom also died of cancer, who also rejected modern medicine approaches. I thought that the acting by both Caitlin Dever as Belle Gibson, and sorry if I mispronounced that, and also Alicia Debnam Carey as Milla Blake was brilliant. The manipulative charm and contradictions of a pathological liar, that is Belle Gibson, was portrayed amazingly. And the show was great in capturing the tension between conventional medicine and alternative approaches. You have the scientists and doctors rolling their eyes, frustrated by the misinformation. And you also have desperate patients who feel ignored by the healthcare system. And then you have the influencers and the self-proclaimed health experts promising easy answers. They give medical advice like they're handing out candy, and they do it so well that people forget to think about why you spend so many years in school trying to understand human biology. And by taking their word in going natural, people take actions without knowing what they're actually doing, falling into the same trap that they criticize with modern medicine and using pills and treatments that doctors give us, except you can find pages and pages of evidence for the pills and the treatments when you can't really do the same for the other approaches. And here's the thing, I'm not anti-alternative. Like I said, I love a combinatorial, evidence-based approach. There are holistic approaches that can certainly complement traditional treatments. If something makes you feel good and it doesn't harm you, go for it. But ignoring data or making up data is dangerous. People get sick, they get scared, and when you're desperate, you understandably want certainty. And the alternative approaches of influencers and the influencers themselves sound a lot more certain in themselves than doctors or scientists. But certainty doesn't exist in medicine or science. A scientist never claims to know everything. We are literally trained to question, to doubt, to test. So why should we trust people who do claim to know everything and dismiss experts entirely? Why should you? In an age where a well-lit TikTok video can have more impact than a peer-reviewed study, influencers have immense power. And this show does a fantastic job highlighting how quickly misinformation can spread and how people can make drastic health decisions based on anecdotal evidence. And look, I get it. Medicine can feel impersonal. The healthcare industry has its flaws. But what's frustrating is this assumption that scientists and doctors are in on some grand conspiracy to keep people sick. Let me be clear. Scientists and physicians devote their entire lives into solving these issues, and they don't even make that much money. And before you roll your eyes to that, remember the amount of years spent in school. Almost all other professions can start making money immediately after undergrad. If you want to make money, you study business and commerce and software. And depending on your school and some luck, you can earn 6 figures as a new grad. Consider a physician who still needs at least 4 more years of school, at least 4 other years as a resident, where you really make very minimal money, especially considering how many hours you work. And by the time your bank account takes a sigh of relief, you're in your mid-30s, and that's still the best possible scenario. A scientist also needs more school after undergrad, and if you stay in academia, good luck in making any decent money. If you go to biotech or pharma as a scientist, yes, better money, but compared to business or tech jobs, nowhere near them. And you can't even work remotely. You have to always be in the lab, including the weekends, because you have to abide by your experimental timelines, check on your cells and your animals. They don't care that it's a weekend. It's a dedication to a cause, to alleviate suffering, to make someone else's life better in one way or another. If you want to get rich, you hit a glass ceiling as a physician or a scientist. You have to transition to business ventures to build more capital, and that's just the truth. This isn't me denying that there are large sums of money circulating in healthcare and pharma, but the ones making the big bucks are usually the execs at the top, not the physicians or the researchers in the lab. There are, of course, physicians who make a lot of money once they're established, and unfortunately, there are those whose practice might have questionable merit. If you want an absolute guarantee that you're not surrounded by any corruption, your best bet is to hang out with animals and plants in a forest. Coming back to research, let's now talk about where the money goes. Drugs are very expensive, and these companies obviously make a lot of money. So where does that money go? As big as the influx of money can be, the outflow is also huge. Biomedical research is so expensive to run. The laboratory spaces, equipment, all the supplies, all of these are bigger expenses than anyone's salary. The tiniest amount of chemicals, good for only 1 or 2 experiments, can cost thousands of dollars. The real winners in research are those who market and sell research supplies. And the prices they set are truly limiting factors, especially for academia, where your funds are much more limited. There can be a machine that can speed up your experiment by days, but it will cost hundreds of thousands of dollars, so you can't afford it. Trust me when I tell you, if there could be a cap on how expensive research equipment and supplies could be relative to their cost of making, research would progress a lot faster. But then again, they rightfully consider the effort gone into developing that product to justify the price, which is often what happens in pharma. You often have limited time until your drug patent expires and other companies can make and sell generic versions. They want a return on the money put in. And so many drugs fail, either while in development or in clinical trials. So when a drug finally completes all trials successfully, the burden of financing other projects also falls on that one drug, so that the company can keep exploring new targets. And I don't think it's fair at all to talk about what pharma does with its money, with the huge operational costs, when we don't do the same questioning for the big tech giants, who probably don't have the same amount of operational costs, yet they spend insane amounts of money for a 20-something-year-old to earn six figures. The luxury a junior coder gets in tech, you don't achieve until you're a senior manager in biotech or pharma. Did or does pharma make mistakes? Of course, human beings are flawed. I know all about pharma's contribution to the opioid crisis and how physicians were tempted all the time with luxury trips and incentives. But it would be naive to think that pharma is alone in this. Social media apps literally sell or share your data to make money. They play a huge role in teaching you what you should want or need. Do you think all of that doesn't change your biology? You're influenced because it changes your brain chemistry. You scroll on apps every day. I bet you can't even read a book without constantly losing focus or getting bored. Because we have all become addicted to fast dopamine and instant gratification that we learned from social media. Or consider alternative medicine approaches. Consider the health camp featured in the show, where all they do is drink juices and perform enemas. Is that camp not financially motivated? Do those families not need to use their savings to be able to afford attendance? Do those apps not charge you for their services? Do the founders of these initiatives not make an insane amount of money? How come simply quoting nature makes them more trustworthy? They're like you and me, human beings capable of thinking and doing both horrible and amazing things, in a constant battle between their id, ego, and superego. So if you're skeptical about the pharmaceutical industry, great, be skeptical. But be skeptical in both directions. Because if your logic is big pharma just wants to make more money, then why would they hide effective treatments that could make them even more money? Investors would love that. The significant money you need for each experiment comes from an investor who invested because they expect a return. Finding a cure in the first place requires money. You don't magically find any real cure without investing significant time and resources into proving it, unlike what you might see in some movies. The money has to come from somewhere. And what investor in their right mind would be okay with spending millions of dollars only to never get their money back by selling the solution? The problem isn't hidden cures or money-driven scientists. It's that cancer is unbelievably complex. So now let's talk about that. Why don't we have a universal cure for cancer? Well, cancer isn't just one disease. It's hundreds of diseases, all driven by different mutations evolving in real time inside the body. Finding a cure is like trying to hit a constantly moving target. Cancer happens when cells acquire mutations that let them grow uncontrollably. All cells in your body carry the genome, which is the assembly of your DNA, your entire genetic information. Genome is like your own personalized book that defines you, and DNA contains the instructions that make up this book. Chromosomes are the organized and accessible sections of the book. Genes, on the other hand, are like workers specialized in each section, converting the instructions into products. Each gene carries out its function by creating proteins. So having the recipe alone, the DNA content, isn't alone. You have to actually make a dish from that recipe. For this, the original recipe in DNA is transcribed into RNA, which then creates the protein, the final dish. The human DNA is approximately 3 billion base pairs long, which is a sequence of 3 billion letters. A mutation is when one or several of these letters either change or get lost or shift while your cells divide to make new cells, which need DNA to also be copied. With every new cell, these 3 billion letters need to be copied perfectly. Any imperfection causes a mutation, and this is normal. 3 billion letters is a huge undertaking. So your body already has mechanisms in place to catch these mutations and kill the cells that carry mutated DNA. Sometimes, depending on where in the DNA the mutation is, your body's own mechanisms aren't enough. What happens with cancer is that the mutated cells gain abilities to divide very quickly to make more of the mutated copies. And they do this at a speed that can surpass the speed of your natural defense mechanisms. Or they can also gain abilities to hide from these mechanisms and grow under the radar. And how they go about it can vary significantly between each type of cancer. The reality is that cancer is a constant battle in your body. Even as I'm recording this, there are likely cancer cells in my body being targeted by my immune defenses or caught by DNA repair mechanisms. This is why the strength of your immune system is so crucial. It's working around the clock to fight both external and internal threats. And keeping your immune system in good shape is essential for it to do its job effectively. But once cancer grows large enough to be diagnosed, that's evidence that your body's own defense mechanisms haven't been enough. No cancer appears overnight. By the time it's detected, odds are it's been growing for years. One of the biggest challenges in cancer treatment is that cancer cells constantly mutate. A drug might be effective at first, but over time, the cancer can develop resistance, changing in ways that allow it to evade treatment. It essentially learns to hide from the drug. While we can categorize cancers based on the tissues they originate from, the genetic variations within each type are practically limitless. Knowing all of this should make clear why modern approaches aren't always enough. And what are the modern approaches? There are the 3 main pillars that you probably know: chemotherapy, radiotherapy, and also immunotherapy. Chemotherapy is a broad attack. It's essentially chemical warfare against rapidly dividing cells. It targets cell division, which is why it's effective against cancer, because cancer cells divide uncontrollably. But the catch is that chemo isn't selective. It also affects other fast-dividing cells in your body, like those in the hair, your gut, and bone marrow. This is why people undergoing chemo often experience hair loss, nausea, or weakened immunity. All cells dividing as part of your biology can be harmed by chemo. And remember how cancer mutates? That's a big problem with chemo. A treatment might initially shrink a tumor, but if even a few resistant cancer cells remain, they can come back stronger and more aggressive. Antibiotic resistance also works similarly. Radiotherapy, or radiation therapy, is more precise. It uses high-energy beams, often X-rays, to kill cancer cells. Because your DNA is susceptible to radiation damage. So just like how radiation can harm healthy cell DNA, it can harm cancer cell DNA to prevent it from dividing and cause it to die. It's a more localized treatment compared to chemotherapy, so it's often used when cancer is confined to one area. But again, normal cells in the surrounding area can also be affected. The challenge is balancing enough radiation to destroy cancer while minimizing harm to healthy tissue. Then there's immunotherapy. Instead of attacking cancer directly, it supercharges your immune system to recognize and destroy cancer cells more effectively. See, your immune system is already capable of fighting cancer. It just sometimes fails to recognize the cancer cells as threats because they're still technically self. They're your own cells. Immunotherapy can work in a few ways. Checkpoint inhibitors are one class. They remove brakes from your immune system so that they can attack cancer more aggressively. Another category is CAR T-cell therapy. It genetically modifies your own immune cells to better recognize and kill cancer cells. And the other category are the cancer vaccines, which help train your immune system to detect cancer before it spreads. Gardasil is an example of this, and it's been incredibly successful in reducing cervical cancer around the globe. Immunotherapy in general is very exciting because it can provide long-term protection, almost like teaching your immune system how to fight cancer on its own. But it doesn't work on all types of cancer, and it can sometimes trigger an overactive immune response, leading to inflammation or autoimmune-like effects. So, to sum up the challenge of treating cancer, it's difficult to treat not only because it mutates, but also because it's a fundamental part of our own biology. Unlike bacteria or viruses, which are foreign invaders, cancer arises from our own cells, making it hard to target without collateral damage. That's why scientists are constantly searching for ways to make treatments more precise, whether through targeted therapies, gene editing, or even using artificial intelligence to predict mutations before they can happen. Ultimately, the fight against cancer isn't about a single miracle cure. It's about understanding its complexity and staying ahead of it with smarter, more adaptive treatments. And while alternative therapies like diet, stress management, natural compounds, or any other method can support health, they don't replace targeted treatments. They simply can't. The body does have mechanisms to heal itself, but sometimes it needs help. And if we respect the body's intelligence in healing itself, we should also respect the intelligence of the people dedicating their lives to understanding the human body. Again, there is no denying that some alternative approaches help people feel better. And feeling better is valuable. But there's a difference between supporting the body's healing mechanisms and rejecting science outright. Healing isn't just about belief, it's about biology, and biology is a very complicated science. The show Apple Cider Vinegar certainly does a fantastic job of showing how seductive alternative narratives can be, especially when the world and diseases feel so overwhelming. But if we truly want to heal, we need to balance openness with critical thinking. Science isn't perfect, medicine isn't perfect, but it's trying. And it's built on a foundation of people who don't claim to know everything, but who dedicate their lives to learning more. So please, please eat well, eat organic, meditate, be mindful of the toxins we are surrounded with. Explore Chinese or indigenous medicine. Explore acupuncture. Look into these long-established practices. But please make sure to apply the same curiosity to modern medicine and apply your critical thinking to both ends of the spectrum. Thank you for being here. Stay informed, stay curious, and please like and subscribe. Santé!